Okay guys, now we're going to talk about simple density measurements, how to get the density of regular shaped, irregular, density of a liquid, and different things. Now let's start. So if you have a density of a regular shaped solid, so basically you don't need anything but the mathematical formula and a balance. So you say density is equal to mass over volume. You want to get the mass, so you have a measuring cylinder and therefore, sorry, a measuring balance or an electronic balance, as you can see. So this is 50 grams red. So let's say the dimension of this is 0.5 centimeters. So you want to get the volume, and this is a cube. So the volume of the cube is the side cubed, so 0.5 cubed. So this is gonna give you, let's do this. So cube, this is gonna be about 0.125. So you do the math, so 50 divided 0.25, so the density of this object is about 400 grams per centimeter cube if we are following that. Okay, now that's for a regularly shaped solid. Now what if the object is not regularly shaped? So we go to this idea of displacement method. So for example, this key has got a mass of 10 grams, so I want to calculate the density, which is mass over volume. So we know the mass already is 10. Now we want to get the volume. Now if you look at this, the water was about, let's say, 25 centimeters cube, and let's say it jumped to about 40. I'm going to round this to 40. So what is the volume of the key? Is the difference between volume 1 and volume 2. So V2 minus V1, which is 40 minus 25, this is going to give you 15. So 15, so 10 divided by 15 is about 0.6666 and so on. So you round this to 0.7. What is the unit? It's very important. There was grams and here is centimeter cube, so gram per centimeter cube. You need to memorize these steps as it comes as a full question. Okay, now let's look about the density of a liquid. Now the idea of a density of the liquid, you cannot measure the mass directly. You cannot put the liquid on a balance, so you need a container. So you need to measure the mass of that container, which in this case is a measuring cylinder, and then you do the same idea that we just done with the volume. So for example, this one started with a mass of 25 grams and it ended to a 60 grams. So the density again is mass over volume. The volume is easily measured using the measuring cylinder. So let's say it is 40 at this point, and the mass was 60 minus 25. So this would give you 35. So this is 35 divided by 40. So 35 divided by 40, this is about 0.875 gram per centimeter cube, which you can round to 0.88 gram per centimeter cube. Also, you need to memorize these steps. You're gonna find it in the notes because it usually comes as a follow-on question. Now, if you have a density of a floating object or an object that really doesn't sink, so the first thing you need to measure is the mass of that object before you do anything. So same, density is mass over volume. You measure the mass before you put it in water, so the water doesn't affect the object. Okay, and then you have to measure what? The volume of a sinker and a water. What is a sinker? A sinker is something that you use to dip the object into the water because it's unsinkable. So what you need to do first is to measure the total volume of the sinker and the water together. And then you're gonna tie it to the sinker, tie the object, place it in the measuring cylinder, and then calculate the volume, which is V2 minus V1. And then you calculate simply the density, okay? Now let's say you have the density of a very large object that you cannot really put in a measuring cylinder. So you use a displacement can, okay? Simply, you just immerse that in the displacement can, but the water should be obviously filled up to this space. Sorry for the graphics. And when you put the object, this displaces a certain volume into the measuring cylinder, and therefore you can know the volume of such a large object, okay? So that's the idea of how to use measurements of simple density. So thank you.